Widely regarded as World War II's premier fighter aircraft, the Focke-Wulf Fw-190 came in at least 40 different models. When it debuted over France in 1941, the Fw-190 caught the Allied air forces off guard, presenting an unexpected challenge. Designed by Kurt Tank at Focke-Wulf in the late 1930s, the Focke-Wulf Fw-190, or Würger, Shrike, became a formidable single-seat, single-engine fighter during World War II. Together with its counterpart, the Messerschmitt Bf 109, it formed the backbone of the Luftwaffe's Jagdwaffe. The BMW 801 radial engine, which powered most models, enabled it to carry larger loads than the Bf 109, permitting diverse use as a day fighter, fighter-bomber, and ground attack aircraft, with limited use as a night fighter. The Fw-190 debuted over France in 1941. Operational over France from August 1941, the Fw-190A showed superiority in all but turn radius to the Royal Air Force's Spitfire M-AV, especially at low and medium altitudes. Its dominance over Allied fighters lasted until the improved Spitfire Mach-9 was introduced. By November-December 1942, the Fw-190 was also making a significant impact on the Eastern Front, excelling in both fighter wings and specialized ground attack units from October 1943. However, the Fw-190A series struggled with performance at high altitudes, typically $6,000 and $20,000 FT and above, limiting its high-altitude interceptor capabilities. Despite attempts to mitigate this through various modifications and new models, such as the B, C, and D variants, and through introducing different power plants and turbochargers, only the D model saw service from September 1944. These modifications eventually gave rise to the Focke-Wulf Fw 152, capable of achieving remarkable speeds at medium to high altitudes, although these and other long-nose 190 variants arrived too late to significantly influence the war's outcome. The Fw-190 earned favor among its pilots, including several of the Luftwaffe's most successful aces, like Otto Kittel, Walter Nowotny, and Erich Rudorfer. Offering more firepower than the Bf 109 and superior maneuverability at low to medium altitudes. According to pilots who flew both, it was considered one of World War II's most exceptional fighter planes. Fw 190. Early design. In 1934-1935, the German Ministry of Aviation, RLM, initiated a contest to create a modern fighter for the ramming Luftwaffe. Kurt Tank entered the Fw 159. Featuring a parasol wing, competing against the Arado R-80, Heinkel He 112, and Messerschmitt Bf 109. Unfortunately, the Fw 159 quickly found itself outclassed, being eliminated alongside the R-80. While the He 112 and Bf 109 showed similar design, the latter's lightweight construction provided a performance advantage unmatched by the 112. Consequently, the Bf 109 was declared the winner on March 12, 1936. Despite the Bf 109 not yet joining squadron service, the RLM, by autumn 1937, sought new fighter designs to complement it, anticipating future international advancements that might surpass it. Hence, the RLM aimed to preemptively develop new aircraft to address potential challenges. In response, Tank proposed various designs, predominantly featuring a liquid-cooled inline engine. Nevertheless, RLM's interest peaked only upon presenting a design powered by the air-cooled 14-cylinder BMW 139 radial engine. Given that this design utilized a radial engine, it wouldn't vie with the inline-powered Bf 109 for engines, addressing the existing scarcity of Daimler-Benz DB6001s. Such competition for engines was an issue for other designs, like the Heinkel He 100 or the twin-engine Focke-Wulf Fw 187. Potentially impeding 109 and Messerschmitt Bf 110 production. After the war, Tank refuted rumors that he had to strenuously advocate for the merits of the radial engine with the ministry. Design concepts. In that era, radial engines in European land-based fighters were somewhat rare, primarily due to concerns about excessive drag. However, Kurt Tank, observing the U.S. Navy's successful utilization of radial engines, believed that proper streamlining could overcome this issue. Specifically, the cylinder heads, being the hottest points on any air-cooled engine, are situated around a radial engine's circumference. Ensuring adequate airflow to cool the engine, particularly at this outer edge, was crucial. Traditionally, maximizing this airflow involved leaving most of the engine's front face exposed, inevitably creating significant drag. In the late 1920s, NACA developed an airfoil-shaped ring placed around the cylinder heads, known as the NACA cowling. To address this, which accelerated the entering air, increased overall airflow, and allowed for a smaller front opening. Tank proposed an additional enhancement to this concept. He recommended situating most airflow components on the propeller, using an oversized spinner with the same diameter as the engine. Consequently, the cowl around the engine was notably simplified, essentially forming a basic cylinder. Air entered through a small hole in the spinner's center, was routed via ductwork in the spinner, and expelled rearward along the cylinder heads. An internal cone, positioned in the hole's center above the propeller hub, intended to compress the airflow, enabled the use of a smaller opening. Theoretically, the snug-fitting cowling also offered some thrust by compressing and heating the air flowing through it. British Spitfire. Regarding the remaining design philosophy, Tank desired more than merely creating a speedy aircraft. He explained his rationale. The Messerschmitt 109, SICK, and the British Spitfire, the two fastest fighters in the world. At the time we began work on the FW-190, could both be summed up as a very large engine on the front of the smallest possible airframe. In each case, armament had been added almost as an afterthought. These designs, both of which admittedly proved successful, could be likened to racehorses. Given the right amount of pampering and easy course, they could outrun anything. But the moment the going became tough, they were liable to falter. During World War I, I served in the cavalry and in the infantry. I had seen the harsh conditions under which military equipment had to work in wartime. I felt sure that a quite different breed of fighter would also have a place in any future conflict. One that could operate from ill-prepared frontline airfields. One that could be flown and maintained by men who had received only short training. And one that could absorb a reasonable amount of battle damage and still get back. This was the background thinking behind the Focke-Wulf 190. It was not to be a racehorse, but a Dienstpferd, a cavalry horse. Extending to the vertical fin. Tank opted for wide-tracked, inward-retracting landing gear for the FW-190, contrasting with the FW-159's problematic design. Specifically, this gear could endure a sink rate of 4.5 meters per second, showcasing notable robustness. Furthermore, hydraulic wheel brakes enhanced its functionality. Consequently, the FW-190 exhibited improved ground handling and experienced fewer accidents than the Bf-109. Unlike the Bf-109's outward-retracting narrow-track gear, the FW-190's structure supported consistent performance and safety. Additionally, the retractable tail gear employed a cable, anchored midway on the starboard main gear, extending to the vertical fin. This facilitated tailwheel retraction, moving it upward along a diagonal track within the fin into the fuselage. Moreover, for some FW-190 variants, an extended tailwheel strut accommodated larger loads, like bombs or torpedoes, under the fuselage. This design, accessed through a triangular hinged panel on the fin's left side, showcased a unique, functional aesthetic and practical mechanic accessibility. Another innovation. In the era, most aircraft utilized cables and pulleys for their controls, which often stretched, reducing control responsiveness. Subsequently, the design team for the new aircraft replaced these with rigid push rods and bearings to mitigate the issue. Also, they prioritized making the controls exceptionally light. Notably, they capped the aileron's maximum resistance at 3.5 kilo to align with the average man's wrist strength. The empennage showcased well-balanced, relatively small horizontal and vertical surfaces. Moreover, the team sought to minimize trim changes at varying speeds to lighten the pilot's workload. Their efforts proved so fruitful that in-flight adjustable aileron and rudder trim tabs became unnecessary. Instead, small, fixed tabs, adjusted during initial test flights, were attached to control surfaces. Only the elevator trim required in-flight adjustment, achieved by tilting the entire horizontal tailplane between 3 degrees and +5 degrees using an electric motor. Furthermore, the new design prominently featured electrically powered equipment, diverging from the then common hydraulic systems. While the first two prototypes had hydraulic main landing gear, starting with the third prototype, push buttons controlled electric motors in the wings for undercarriage operation, stabilized by electric up and down locks. The armament was also electrically loaded and fired. Tank held a belief that field use would validate electric systems as more reliable and durable than hydraulics, considering electric lines were less susceptible to enemy fire damage. Fw-190 higher stalling speed. Like the Bf-109, the Fw-190 had a relatively small, high-wing loading wing planform. This design approach offers a specific performance trade-off. Smaller wings create less drag, allowing the aircraft to fly faster and potentially extend its range. Conversely, this also results in a higher stalling speed, reduced maneuverability, and diminished high-altitude performance. The wings measured 9.5 m 31 ft2 in span and covered an area of 15 mm 160 sq-ft. Designers utilized the NACA 23015.3 airfoil at the root and NACA 23009 at the tip. Meanwhile, earlier aircraft usually featured canopies made of small perspex plates in a metal framework. For instance, the Mitsubishi A6M0 employed a heavily framed, yet all-around view canopy. Such a design significantly limited visibility, particularly to the rear. However, the advent of vacuum forming enabled the development of the bubble canopy, which could be placed above the cockpit and offered vastly improved visibility. BMW crafted cowling. The Fw-190's canopy design, crafted by Tank, used a frame encircling the perimeter and only a brief seam along the top. Lastly, selecting the BMW 801 14-cylinder radial engine also introduced a BMW-crafted cowling system with an integrated radiator to cool motor oil. An annular, oil cooler core was embedded in the forward cowl behind the fan. The core of the oil cooler was in contact with the main cowling's sheet metal, being situated inside the BMW-designed forward cowl. Together, the metal ring and cowling formed an S-shaped duct containing the cooler's core. As air flowed between the cowl and the outer lip of the metal ring, it produced a vacuum effect, drawing air across the oil cooler core. The system could control the cooling airflow rate by adjusting the metal ring. This intricate system aimed to reduce additional aerodynamic drag, aid oil warming during starting, and ensure cooling even when stationary. However, this design also positioned the radiator vulnerably, necessitating increased armoring as the war progressed. Hermann's Wild Sow Technique de Sow. Starting in mid-1943, Fw-190s began serving as night fighters, countering the escalating RAF Bomber Command offensive. One of the first groups to experiment with single-engine ground-controlled night fighting was the Nachtjagdkommando Fw-190. Operated by IV Gruppe Jagdwaffe 3, or JG3, it played a pivotal role in early trials. The primary Nachtgeschwader were eager to introduce a new fighter, as their twin-engine variants lagged behind the de Havilland Mosquito fighters and bombers. NJG-1 and NJG-3 maintained Fw-190s on standby, supplementing the Messerschmitt Bf 1 and 10 and Junkers Ju 88. However, the superior performance of the Fw-190, compared to the other two models, struggled to counterbalance the challenges of nighttime operation. These test runs yielded few, if any, confirmed aerial victories. In April 1943, Major Hajo Hermann established one of the first units explicitly for employing Fw-190s in night fighting, named Stab Versuchskommando Hermann. This unit utilized standard A4s and A5s from dayfighter units to intercept bombers, using searchlights and other visual aids for navigation and target acquisition. The RAF's introduction of window during the Battle of Hamburg in July 1943 nullified standard night fighter Himmelbett procedures. This development amplified the urgency of refining Hermann's Wilde Sau technique and innovating new night fighting strategies. Frequent write-offs. Contrary to restricting Fw-190s to ground control interception protocols, pilots freely patrolled bombed areas, attempting to locate bombers via the ground fires beneath them. This strategy persisted as a core night fighter tactic until May 1944. Subsequently, STV Hermann expanded into Jagdgeschwader 300, JG300, JG301, and JG302. Initially, all three units borrowed their aircraft from dayfighter units. However, due to the frequent write-offs resulting from the perils of night operations, especially prominent in winter with many pilots forced to bail due to difficulties finding safe landing spots, Protests from day fighter units ensued. Ultimately, all 3 Wild Sow units received their designated aircraft, often retrofitted with exhaust dampers and blind-flying radio apparatus. Another noteworthy unit was Nachtjagdgruppe 10, NJGR-10, utilizing FW-190A4R11s to A8R11s, modified to equip FUG-217 or FUG-218 radar mid-VHF band technology. FW-190 Sturmböcke Interceptor. Heavy U.S. Army Air Force's bombers, notably the durable B-17 Flying Fortress, presented a significant challenge to German fighters. Specifically, the armaments on the Bf-109 and FW-190 proved insufficient for effective bomber-destroyer operations. Furthermore, deploying B-17s in combat box formations enabled them to deliver massed firepower from over 100 Browning AN/M250 caliber machine guns. Although the Luftwaffe initially used Zerstörer twin-engine Messerschmitt Bf 110G bomber-destroyers successfully against unescorted Allied bombers, their effectiveness waned. Moreover, when USAAF fighter escorts intervened in late 1943 and early 1944, they devastated these Luftwaffe units. Transitioning to another strategy, the Luftwaffe reconstituted 2 former Wildesau single-engine night fighter wings for usage. Namely, these were Jagdwaffe 300, JG 300, and JG 301, and they primarily utilized Sturmböcke. Notably, JG 3 also developed a specialized group of Sturmböcke. Additionally, the FW-190, a rugged interceptor, originally designed for considerable combat resilience and a potent attack, became a focal point for anti-bomber operations. Subsequently, Focke-Wulf adapted the wing structure of the FW-190A6 to accommodate larger weaponry, enhancing its anti-bomber capabilities. Cannon pods. The standard armament of the aircraft expanded from 4 MG-151 Tauncher 20s to 6, adding 2 more in underwing cannon pods. Subsequently, this model was named the A6R1, Rüstsatz, or Field Conversion Model. The first delivery of these aircraft took place on 20 November 1943. Soon after, brief trials led to replacing the twin cannon with the Mk108 30mm autocannon in the outer wing, redesignated as the A6R2. Notably, these cannons featured blowback operation, electric ignition, and belt feeding. Additionally, the simple and economically constructed 30mm Mk108 largely comprised pressed sheet metal stampings. Next, the A6R4 iteration introduced the GM1, nitrous oxide, boost to enhance the BMW 801 engine's high-altitude performance. Also, they added 30mm of armored glass to the canopy for added protection. FW-190, a formidable bomber-killer. Furthermore, the A6R6 model incorporated twin heavy-caliber Würger Granit 21, BR-21, unguided, air-to-air rockets, fired from underwing launchers. The considerable modifications, especially the robust firepower, transformed the FW-190 into a formidable bomber-killer. Moreover, the A7 model emerged in November 1943, replacing the cowl-mount synchronized 7.92mm MG-17 machine guns with synchronized 13mm MG-131s. The A7R variants were equipped to carry 230mm Mk-108s and BR-21 rockets, amplifying its efficacy as a Zerstörer bomber formation destroyer. Finally, the A8R2 became the most numerous Sturmböcke aircraft. Fiesler built approximately 900 in Kassel, equipping them with 30mm Mk-108s in their outer wing panel mounts. While the FW-190 became a formidable bomber-killer, the added armor and upgunning with heavier caliber firepower reduced its maneuverability. Consequently, it became vulnerable to Allied fighters, necessitating escorts by Bf-109s. When the Sturmgruppe functioned as intended, their impact was devastating. Willy Unger, Luftwaffe Ace. The heavily armored engines and cockpits of the FW-190As enabled them to execute attacks from astern. Furthermore, gun camera films indicate that pilots often pressed these attacks to within 100 yards, 90 mm. Willy Unger, Luftwaffe Ace and recipient of the Knight's Cross of the Iron Cross, said, "Advantages: wide undercarriage, large twin-row radial engine which protected the pilot from the front, electric starter motor and electric trim system. Disadvantages. There was a danger of turning over when braking hard on soft or sandy ground. In combat against enemy fighters, more awkward because of the heavy armor plating. Strong at low altitude, inferior to the Bf-109 at higher altitude. In my opinion, the Fw-190, in this version, was the best aircraft used in the formation against the Wehrmacht's fellow Luftwaffe ace. Richard Franz also commented, "When we made our attack, we approached from slightly above, then dived, opening fire with 13mm and 20mm guns to knock out the rear gunner. And then, at about 150 meters, we tried to engage with the Mk-108 30mm cannon, which was a formidable weapon. It could cut the wing off a B-17. Actually, it was still easier to kill a B-24, which was somewhat weaker in respect of fuselage strength and armament. I think we generally had the better armament and ammunition, whereas they had the better aircraft." Fw-190D9 Dora. The ninth version of the Fw-190D series, nicknamed Dora, is often deemed the best U-2 German propeller-driven fighter at mid to low altitudes. Furthermore, many warbird enthusiasts regard it as particularly attractive. A significant change from earlier Fw-190 models was the introduction of the Jumo 213A inline engine. This transition entailed moving from the bulky, open radial style to a more aerodynamic, domed, cone-shaped nose. Rather than prioritizing armor and heavy-caliber artillery, the Fw-190D9 showcased superior maneuverability and speed. Nevertheless, it boasted two cowl-mounted 13mm MG-131 heavy machine guns and two 20mm MG-151 Chassaimer 20 autocannons in the wing root, all synchronized to fire through the propeller arc. Additionally, the Fw-190D9 offered remarkable speed, superior climb rates, and generally better handling than both its predecessors and enemy rivals. Consequently, it proved a formidable adversary to the P-51s and later model Spitfires. Fw-190 F8 Ground Attack. The Fw-190F series, derived from the A series, were designed as close support aircraft on the battlefield. Subsequently, the long-range attack G series developed when engineers sought to extend the F series range. The first Fw-190F configuration was tested on an Fw-190A0U4 model. Similarly to the Rüstsätze, Umrüstbausätze kits served the same purpose, but were typically factory-fitted. Enhanced compressor. Successful early tests with centerline and wing-mounted bomb racks gave further development a green light. New armor was added to the fuselage bottom and cowling to protect the fuel tanks and pilot from ground fire, complemented by stronger landing gear and outer wing-mounted armament. Consequently, this new configuration, A4U3, was eventually renamed the Fw-190F1, initiating the series. The F8 aircraft, derived from the widely produced A8, hosted an enhanced compressor and fuel injection system, enabling marginal performance improvements at low altitudes. Additionally, it featured a new Fw G16ZS radio unit, enhancing communication with Allied ground troops. The Fw-190F8 maintained firepower akin to the Fw-190A8R8, employing two 20mm MG-151 20 cannons in the wing roots and two 13mm MG-131 machine guns above the engine. Special Rüstsätze and Umrüstbausätze kits introduced bomb racks or expanded fuel tank capacity, providing additional range or improved ground attack capability. Moreover, in 1944, the Luftwaffe investigated various missile launching systems on the F-series, aiming to craft a more potent anti-tank aircraft to contend with Soviet tanks on the Eastern Front. Outstanding legacy. The Fw-190 served on every major Luftwaffe combat front after 1941, excelling in various roles. It first encountered combat on the Western Front in August 1941, demonstrating superiority over the Mk5 Spitfire. However, the Spitfire maintained a notable advantage with its superior turn radius over both the Fw-190 and the Bf-109. Nonetheless, the Fw-190 surpassed the Spitfire Mkv in numerous aspects, including roll rate, speed, acceleration, and dive performance. Consequently, the Fw-190's addition to the Jagdwaffe enabled Germans to repel RAF attacks and achieve local air superiority until the Spitfire Mk Nadamaya's summer 1942 debut. In June 1942, Oberleutnant Armin Faber of JG-2 inadvertently landed his Fw-190A3 at a British airfield, granting the RAF an opportunity to pit the Mk9 against the 190 and develop counter-tactics. Over its production span, there were more than 20,000 Fw-190s across all variants. The showcased Fw-190D9 was allocated to the JG-3 Udet-Geschwader. Named after Ernst Udet, Germany's top surviving ace from World War I, JG-3 stands out as one of the Luftwaffe's most renowned fighter units.